Draw the arrangement of particles in a solid. In a solid, you're going to have particles that are in a fixed position. They're very, very close to each other. They're going to be moving a tiny, tiny bit due to the energy, the kinetic energy that they have, but they're going to be moving around a fixed position, not moving very much at all. Draw the arrangement of particles in a liquid. In a liquid, we are going to have a much looser arrangement of particles. They're still going to be very close, they're still going to be touching, but they're going to be moving, but not around a fixed position. Draw the arrangement of particles in a gas. In a gas, you're going to have big spaces between the particles. They're going to be moving lots of kinetic energy here, and they're not generally going to be touching. What is it called when a solid turns into a liquid? This is melting. What is it called when a liquid turns into a gas? This is evaporating. What is it called when a gas turns into a liquid? Condensing. What is it called when a liquid turns into a solid? This is freezing. What is the boiling point? The boiling point is the temperature at which a liquid will turn into a gas. The condensing point is the temperature at which a gas will turn into a liquid. Now, people frequently get confused thinking that if the boiling point is 100, that the condensing point needs to be the 99 or 101. They are exactly the same value. So for any given liquid, the condensing point and the boiling point are the same value. They're just going in different directions. That confuses people lots and lots. So what does S mean? It means we have something reacting in a solid state. L is something reacting in a liquid state, and this is going to be water. G means we have something reacting in a gas state, and AQ means we have something reacting in an aqueous state, which means dissolved in water. What is ionic bonding? This is the transfer of electrons from a metal to a non-metal. How are ions formed? This is the gain or loss of electrons. A metal is going to form positive ions, and a non-metal is going to form negative ions. Where a metal's on the periodic table, they are on the left-hand side, and non-metals are on the right-hand side. An ionic bond is an electrostatic attraction. Draw a dot and cross diagram to show the bonding in sodium chloride. So sodium has one electron in the outer shell. It is going to lose that one electron. It is going to become a positive ion. Chlorine has 7 electrons on its outer shell, and it is going to gain the 1 electron from sodium, so it is going to get a negative charge overall. Positive and negative, they're going to be attracted to each other. Draw a dot and cross diagram to show the bonding in magnesium chloride. Now, magnesium has 2 electrons on its outer shell. It is going to lose both of those, and it's going to become a 2+ ion. Now, because chlorine has 7 electrons on its outer shell, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1 electron from magnesium is going to go to both chlorines, like this. They are both going to get a negative charge, and we are going to have 2 of them overall. So the formula for magnesium chloride, and it's always worth adding this on at the end of an exam question about this, because sometimes they give marks for it and sometimes they don't, is MgCl2. Draw a dot and cross diagram to show the bonding in magnesium oxide. So again, we have magnesium. It has 2 electrons on its outer shell, so it is going to become a 2+ ion. Oxygen has 6 electrons on its outer shell. 1, 2, 3, 4, 5, 6 to get up to 8. It gets both of them from magnesium and then forms a 2- ion. So we're going to get MgO in a 1-to-1 ratio for that. What is covalent bonding? This is the sharing of electrons in non-metals. List 6 simple covalent compounds. Now, some of you will have noticed that there are 5 below, but you need to know lots of them. And you need to be able to identify them. So then one of the easiest ways to identify them is just to learn them. So there is hydrogen, water, oxygen gas, methane, ammonia, nitrogen gas. How many have I got? 6 there. Give the formula of oxygen gas. Oxygen gas is O2. The majority of gases, apart from the specific examples I showed you here and a few other ones you need to know, are going to have a 2 after them. So oxygen gas is O2, nitrogen gas is N2. Hydrogen chloride is also known as hydrochloric acid, so that is HCl. Ammonia, NH3, methane, CH4. And yes, I do expect you to know all of these. Give the formula of hydrogen gas. Hydrogen gas is H2, water is H2O, carbon dioxide is CO2. And please, please, please make sure, especially with carbon dioxide, that your big letters are big, your small letters are small, and your numbers are small. In the exam, this will not get you any marks. This will not get you any marks because CO, a little bit like that, is cobalt. So please, 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 I want to find an English teacher to argue this with, but I think that capital letters and lowercase letters are more important in chemistry than they are in English. Draw the bonding in water. I'm going to draw this for you 2 ways. You need to know both different ways. H, and then in the middle we have oxygen, so that is our line diagram or our stick diagram. Then we can use that to draw our dot and cross diagram. So we have 3 overlapping circles. Now I know lots and lots of you are very concerned about how your neatness. We do not need to worry about neatness in chemistry. Now hydrogen has 1 electron in its outer shell, so 1 cross from each of them goes into the little sharing zone. 1 dot from oxygen goes into a little sharing zone. Oxygen has 6 electrons overall, so another one goes up here. That's 4, 5, 6. There's water. Carbon dioxide. We have 2 oxygens double bonded to a central carbon in the middle there. Oxygen, carbon, oxygen, oxygen, carbon, oxygen. Carbon has 4 electrons and they both get shared. I realise I've drawn these a little bit small, and they both get shared in the middle because it's a double bond. Oxygen has 6 electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is one of the more complicated ones, but they do ask complicated questions in an exam, so learn it. The bonding in chlorine gas. Chlorine gas is Cl2. So we've got chlorine, we've got chlorine, we've got 2 overlapping circles, chlorine, chlorine. Chlorine has 7 electrons on the outer shell. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, no. 1, 2, 3, 4, 5, 6, 7. So the mistake I made there is that even though these are both the same, because it's a dot and cross diagram, you have to indicate to the examiner where each of the electrons are coming from. So one needs to be dots and one needs to be crosses. Draw the bonding in nitrogen gas. Another nasty one here because nitrogen gas has a triple bond. So we only need 2 circles, nitrogen and nitrogen, but we need to have 3 electrons from each in the middle. Nitrogen has 5 electrons, so it's 3 there, 4, 5. Doing the other one now is dots, 1, 2, 3, 4, 5. You will notice that each nitrogen now has 8 electrons circling it. 6 in the middle region here that are shared, and then 2 extra that just go around cis electrons. So 6, 7, 8, 6, 7, 8. This is one of the more complicated ones, but if you just learn the picture, if it comes up in the exam, you should be okay. Draw the bonding in oxygen gas. Oxygen gas is O2 and it is a double bond. So we need big circle, little circle inside, big circle, little circle inside, dot and cross. You have double bonds, we need to share 2 electrons in the middle. 1, 2, 3, 4, 5, 6. For the 6 electrons that oxygen has on its outer shell. 1, 2, 3, 4, 5, 6. Now each oxygen has 8 circling it. Draw the bonding in hydrochloric acids. That is HCl, hydrogen, chlorine. Hydrogen has 1 electron on its outer shell, so that pops in there. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7. Nice easy one there after oxygen and nitrogen. Draw the bonding in ammonia. Ammonia is NH3. So those are N, hydrogen, hydrogen, hydrogen. Each hydrogen has 1 electron on its outer shell, so they go in there. Nitrogen has 5. 1, 2, 3, 4, 5. Draw the bonding in methane. Methane is CH4. So circle in the middle for carbon, hydrogen, 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 hydrogen. Oops, that is a bad circle. Like I said, neatness doesn't matter, but accuracy does, and it only overlaps one thing. Hydrogen has 1 electron on its outer shell, so it can share that 1 electron. Carbon has 1, 2, 3, 4 electrons to share. Okay, I know there was a lot of drawing there, but I really cannot think of any other simple covalent compound that the exam board could realistically ask you about. So learn all of those ones, and if you can think of any other ones you want me to draw an example of, just let me know. So in a covalent bond diagram, what does each line represent? So where I've drawn these diagrams here, I've drawn lines, and each line represents 2 electrons. So if we look at nitrogen here, it's a triple bond, so there are 3 lines, there are 6 electrons being shared in the middle. Give 2 examples of giant covalent compounds. We can have diamond, graphite, or silicon dioxide, which is sand. How does metallic bonding arise? This is when we have positive particles sitting in a sea of free delocalized electrons. I know there are a lot of buzzwords in there, but the exam board like them. Why do metals have high boiling and melting points? Because it takes lots of energy to separate them. How are the atoms in a pure metal arranged? They are arranged very neatly in layers, and because they are arranged in layers, it means they can slide. The exam board love these words. So the words the exam board love are layers and sliding, and this makes pure metals soft. how are the atoms in an alloy arranged? Now, alloys have different sized atoms in them, so when you try and arrange the metals in a layer, it doesn't work. So we have no layers in an alloy, and because we have no layers, there is no sliding. No layers, no slide, which makes it hard. Why do people use alloys and not pure metals? Because alloys are hard and pure metals are soft. How do metals conduct electricity? This is the movement of free electrons. Describe the structure of an ionic compound. In an ionic compound, you are going to have positive and negative ions sitting next to each other. This is going to be generally a lattice structure, so a cuboid structure. And remember, it's not just going to be one positive and one negative. There are going to be lots and lots and lots of them all lined up together, making it very, very strong. So the properties are, we're going to have a high melting point and boiling point, and it's only going to conduct when molten or dissolved. Not when it's solid, because when it's solid the ions are not free to move around, so it can't conduct electricity. I'm just changing colour so you can see this simpler. Describe the structure of a simple covalent compound. This is going to be small, like the ones we've talked about on the previous slides. It's going to be small, maybe 2 or 3 things. The properties are that it's going to have a low melting point and boiling point, and it doesn't dissolve in water. The structure of a giant covalent compound, again we are going to be talking about something like a lattice here, and it's going to be very large, it's going to be interconnected. The properties of a giant covalent compound, this is going to have a high melting point and a high boiling point, and it does not conduct electricity. What is a monomer? A monomer, if we look at the word here, the mono means one, the mer means bit, so this is just a 1 bit, a monomer. A polymer, poly means lots, mer means bit, so a polymer is lots of bits added together. A structure of a polymer is going to be lots of bits added together. Which elements are both diamond and graphite made from? And none of you noticed, hopefully none of you noticed, that they're both made from carbon. Describe the bonding in diamond. Now diamond makes 4 carbon bonds, which means it's going to have a very large lattice interconnected structure. Describe the difference in bonding between diamond and the bonding in graphite. Diamond makes 4 carbon-carbon bonds and graphite makes 3 carbon-carbon bonds, which means diamond is going to be this massive interconnected lattice, whereas graphite is going to have layers. And because it has layers, it's going to affect the properties of it. So layers means sliding, which means it's going to be soft, and in between these layers we're going to have another electron, which means it is going to conduct electricity. Graphene is incredibly thin, it's just 1 atom thick of carbon, which means it's going to have a very, very flexible properties. It's also going to conduct really well, so it's really good for using in circuits and microcircuitry. Fullerenes can be used in drug delivery systems. They're also really good, all of this graphite is really good for lubricants. Describe the structure of fullerenes. Now, fullerenes are where we have carbon, but they're arranged into like little balls. They're little cages or sphered cages. Which is why it's going to be good for drug delivery, because you can just pop that in there. Whereas carbon nanotubes is going to be where you have your sheets of carbon and they are bent around into a tube. So these are incredibly strong and incredibly useful. Unless you're surprised that is in a tube shape. Right, last few questions here are for chemistry only. So, what are the size of nanoparticles? Now, nanoparticles are made up of atoms, so they're bigger than atoms. Then we're going to have nanoparticles, and we're going to have everything else. So, nanoparticles are very, very small. The only thing we can consider to be smaller than them are actually going to be atoms. Why do nanoparticles have different properties? It is because they have a very large surface area. What can nanoparticles be used for? I mean, the list of things here are absolutely endless, but again, we can go for drug delivery, communications. They're using sunscreen, they're using loads and loads of different things. The advantages are that it's going to be improved. So improved medical benefits, communications, design, loads and loads of things. The disadvantages are the unknown, and people don't like the unknown. There we go, guys. Lots of questions. Very, very long video here. I hope you found it useful.